Okay, we're just not gonna have chat this time, alright? Alright, technical issues. In order for you guys to listen to this, go into the stream because I'm too lazy to switch the Zoom live stream share screen thing. Actually, you know what? I'm not gonna be like that.
Where do you see it? I don't see it.
Okay. So, sorry for the technical difficulties. Today we won't have any questions because the chat is turned off. But we can, I guess, ask questions in the WeChat after this is all over. So today's lesson, we're gonna go over why you would ever want to learn how to program, and what? It says I'm streaming. Oh my god. Okay, so today we're going to be learning why you would ever want to learn programming, the different languages, and their special features, and then we're going to go over how to install Python via python.org.
I'm seeing a different image on Zoom video call and the YouTube one.
So to start it off, we're going to learn the differences between an interpreted versus compiled programming language. So every single program, it has a set of instructions, so that includes all its commands, and like all its functions, defining its variables and stuff. And so basically, wait.
Who is watching?
Oh wait, this there. Um, okay. So, let's restart. Alright, so, in order to start off learning about programming, we need to know why we would ever want to learn programming, the different languages, and why each one is special, and also how we're going to be able to install the compiler and actually start programming. And so one of the most basic things is learning the difference between an interpreted language versus a compiled language. So each language has its own set of instructions, so that includes its methods, that includes all its defining variables and stuff, and defining classes. And so each language, it will have its own specific set of instructions. However, over all of these different languages, the instructions are going to look very similar to each other. So in order for when you type something inside a compiler and you run the program, what the compiler does is it takes the code that you just wrote and it converts it to a binary form so that the computer can then read the code as machine code so it can perform its actions, because we now know that a computer can only process binary, which is 0 and 1s. So in an interpreted language, the source code isn't directly translated by the target machine, but it uses something known as an interpreter that reads and executes the code, in contrast to a compiled language where the machine directly translates the program into computer code. So in more like human terms, I guess, we could think about this example given about a hummus recipe. So you can either follow its directions and try your hardest, even though it's written in a language that you don't know. And so basically someone has already translated it to English for you, so it's easy for you to read the English version of the recipe and make the hummus yourself. And so this recipe would kind of be like the compiled version. So basically, in the compiled version, your code, which is essentially the ancient Greek, has been translated into binary for the computer. And so as a result, the computer can process the code fairly quickly and efficiently. And so the second way is you know somebody who knows ancient Greek. And so when you make the hummus, instead of going ahead and trying to read it yourself, you have an interpreter for you. And so your friend will then interpret it line by line as you make the recipe. So now that we have a better idea of what the compiled language and interpreted languages are, then then now we can see which languages are compiled and which languages are interpreted. So the pros of a compiled language. So the compiled languages directly convert it into machine code, so they are very fast and very efficient to execute the interpreted languages. And so they also give more control over the hardware aspects. However, the problem is that for these compiler languages, as you have more access to the memory and the CPU usage, that means that it's also easier for you when you make a mistake to kind of destroy your computer. And so some languages that use this are like C and C++, which are more common, and here are some more uncommon ones. So interpreted languages. So interpreted languages go through a program line by line and execute each program. And so interpreted languages are very slow in comparison to all of the compiled languages. That's why when there's like programming competitions and things like that, you will generally see the people who are faster use C++ rather than interpreted languages like Python, JavaScript, and Ruby. And so the pros of this is that since it goes line by line, it will catch your mistake much quicker than you would than if you had gone ahead and gone with a compiled language like C or C++, where it translates the entire file. So here's a list of like the advantages and disadvantages of the compiled and interpreted languages that you can look at. So now that we've kind of looked at these two big groups of languages, we can get into why would you want to program. So programming is essentially allowing yourself to manipulate the computer's binary calculations to complete tasks that you write. So normal tasks like addition, adding 1 plus 1, you can do fairly easily. Now, the point of programming is to complete very lengthy tasks that you wouldn't want to complete yourself and allow the computer to do it for you. And so that's why when you program, when you write your code, you need to make sure that whatever you have in plan, you've already worked out the logic and the kinks. Because in the end, all the computer is doing is it's calculating exactly what you tell it to do. So now that we've looked at that, we can now look at some of the more common languages. So the languages I'm going to go over today are Java, C++, C, and Python, as well as Robot C. So we'll save Python for last because that is going to be our main platform moving on. So why don't we start off with Java. So Java. So Java is a programming languages that was released by Sun Microsystems. So it was later bought by Oracle. So that's why when you go to when you go to Oracle and you try and search up any Java method, it will give you a brief explanation, and it will give you why, like, what the method does and how to properly use it. And it also allows you to download a lot of Java IDEs and JDK. So the reason why Java is special is because it is an object-oriented programming language. And so you can see that right here. So that is probably the main plus of using Java. So when you write a Java program, you are mandated to write a class. And so the reason why having an object-oriented program is so good is because it allows you to organize your material very, very well. And so when you run through your programs, and if it's a fairly big project, then Java will definitely help you be able to organize your files better and make sure that, like, you have your main classes sorted out, and you have your main methods all organized in a way that's it's fairly easy to read. Now, another plus of this is because the development cycle is much faster, because Java technology is an interpreted language. So this doesn't mean that the runtime will necessarily be faster than the compile time, but when you run a program, the compiler will catch your mistakes much faster, because we know that it will compile it line by line. So it will catch each mistake line by line rather than compiling your entire project at one time. And so Java is one of the most widely used computer languages. And so from my point of view, I think it's a very good language to learn after learning a simpler language like Python. Its syntax is slightly more standardized, so the actual code itself might be longer, but it will allow you to run through your logic much faster than, say, a Python program would if you didn't use the proper data structures and methods and classes. And Java, I would say it's rather strict, so if you don't always want to follow it, that's why we're going to move into languages like C and C++. So we'll start off with C. So C is a general purpose language. So it was developed in 1972, so it's a very, very old language. And so C was used to write an operating system known as Unix. And so nearly all of the application programs that we know of right now have been written using C through the Unix. And so C is a pretty easy to learn language. It's kind of similar to Python. I would say closer than it is to Java. It's a fairly structured language, and so it's very good at like doing like pretty simple programs. And so the reason why it's named C is one, it was developed after a B language was introduced, and so why would we want to use C? So C is used to write a lot of the technical things around us. That includes our operating systems, a lot of like the text editors, even some languages are written based off of C. And so C is a very, very old language. It's not really outdated. It's just it doesn't really have a really special function like Java is to like being organized and making sure that you reuse your code properly using classes and stuff. So after C, there's C++. C++. So C++ is a pretty it's a very, very efficient programming language. So this is probably the best example of a compiled language that we can find. It is very, very fast at compiling, and it gives you the, I guess, ultimate access to your hard drive, your CPU. So it will always run the fastest compared to all the other languages that we're going to talk about, like whether it's Java or C or Python or Robot C. C++ will always outperform it. However, because you can outperform using C++, this means that it's you're more liable for you can cause more damage to your computer if you like run a program without like using a compiler and checking your code, because it can like take up too much of your RAM or something like that, and so it will easily like crash or break your computer if you don't use it properly. So C++ is a language that you can also use classes in. You're in fact encouraged to use classes. Now, the way C++ gives you more access to your memory is something known as a pointer. So a pointer is essentially it does what its definition is. It points to something. So what it points to is a space in the memory, and so in the memory, it can point to anything from an integer, so any variable that you might define, all the way to an array list, and even to methods. So what's so special about this pointer is normally when you write something, say in Java, you define an array list, and you add variables into it. Normally, you would add like integers, or you might even add like a special object or something that you created using a class. However, you cannot add functions. And in C, you can add functions. And so, in C++, sorry. In C++, you can add functions. And so, this is important because it allows for ease of access. So, the next language we're going to cover is going to be Robot C. So, Robot C is essentially a specialized form of C. So, for those of us who are doing Vex Robotics, so in the IQ division, not in the VRC division, because in the VRC division C++ is used. In the IQ division, Robot C is one of the recommended languages, as it is developed especially specialized just for the operating system of the robot brain. And so Robot C is based off of C, obviously. And so its commands, its functions and stuff, it has a library of it devoted just to VexIQ. So that can be like turning a motor, defining a motor variable, creating an object or something like that, creating methods and stuff. So all of these functions are located in a library that's special to just Robot C, and it is branched off of C, so obviously that means that its format and how it looks just like C. So finally, we're going to get to the language that we're going to be using for the rest of the course, which is Python. So we're going to get a little bit more detail into this. So Python is an interpreted language. So that means that it will compile it line by line. So essentially, when it goes line by line, it will be able to catch its mistakes faster. So Python, you don't need to compile your program before executing it, because when it gets sent to the interpreter, it will compile it for you. And so what's special about Python compared to many of these other languages is that it is an open source program. So the reason why it's so special to be an open source program, that means that what you can do is you can go through the base code itself, the code that was used to write Python, and you can tinker with it. Obviously, you like copy it into your own files, and you can tinker it, and you can change the code. So we can look through some of the things that this website offers, learning about what's so special about Python. Okay, so the reason why we're using Python as the language that we're going to go with is because it is a very simple language. So the code that you're going to write using Python, it's going to be very similar to something that you would say in like a regular sentence, compared to other languages. So it's very close to regular English. So, as a result of this, Python is very intuitive, and it's a great first step when learning a language. However, it's not exactly a final step. Great recommendation would be to move on to either Java or C++ to develop your skills in code reuse a little better. So, Python, it's very easy to learn and read. Its library of functions and stuff, it's very, very broad. And so it includes functions that let you, like in math or making doing GUI or stuff like that. And another thing about Python is that Python is a great base for artificial intelligence. So I won't get too detailed into that, but it's usually the recommended language for that. So another advantage of Python is that since it's an open source program, you can use it for free, whether it be for home and work. And so compared to Java, I mean, it doesn't cost money to use it yourself, but if you were to like start a company or do it for anything that's related to business, to making money, then you can no longer use Java for free, and they will charge you for it. And so, in addition to this, since Python is an open source program, that means that not only do you have compilers you can download, but there's also compilers you can just use online. And so one of the compilers that we will be looking at is REPL.it. So what does REPL stand for? So REPL stands for read the user input, E for evaluate your code, P for print any results, and L for looping back to step 1. So this four-letter what do you call it? Four-letter thing, I forgot. Acronym, yes, four-letter acronym covers the majority of what you will be learning in programming. So first off is reading the user input. So reading user input includes typing in from the keyboard any images, any text files, anything you're inputting. It can even be hard-coded. Next is evaluating your code. So that means that you need to be able to work out what your code is trying to do. And so when you work it out, you need to make sure that it works out efficiently. And so 3 is printing your results. So this is output. So not only so the reason why in REPL it can only print results is because it's an online compiler, so it doesn't have direct access to your files, nor does it have access to your microphone or something like that. And finally, looping. So looping is also very important, so that you don't have to write the same code over and over and over again. So this is how the compiler looks. You can try it out yourself later, but what we will be using it for is writing the basic program Hello World. Alright. So the basic program is print, and so this is going to be in Python 3, so you're going to need to use parentheses. In Python 2, you don't need to use parentheses. And so the basic program that every programmer will use is printing Hello World. So we're going to run this, and so as you can see, it prints Hello World. So in order for you guys to do this, you guys can obviously use the online compiler if you want, but in order to do it yourself, like offline or something, and have it downloaded to your computer, we're going to go to python.org to go and show how you download it. So over here, when you go to the Python website, you're going to see a download space right here. So you're going to click on it. And so you're going to see all these features and stuff, and then you're going to go down over here to files. So these are files you're going to you can download. So what we're going to be doing is you can go with the Windows file right here. So it is it's embeddable zip file. So essentially when you download it, it's a zip file, and so you're going to need to extract it to wherever you want to download it. And so there's a couple good tutorials if you want to know like the best place to like save it and stuff. But essentially this is how you can download Python, and so you can open it up on your own computer, and so you can like write the hello world program, and you can write the programs that we will write later on in this class. And so that'll be all for today. Thank you for listening.